All right, I wanted to go over the lesson for 2.6 and 2.7 as well as the homework. So here is how we started the lesson. You had these four different equations and the students were trying to solve them by guessing and checking. They found that every single one of the equations had a solution that was x equals 3. The equations appeared to be different, but when you tried to figure out what the value of x was that made it true, aka the solution, every single time you got x equals 3. And what we talked about was the reason why they have the same exact solution is because they're all equivalent equations. For example, if you look at equation in B and you look at the equation in A, they are equivalent because all you would end up doing is adding 6 to one side of the equation and adding 6 to the other side of the equation. And the result is basically an equivalent equation. Meaning you can do legal moves, either adding something to both sides, subtracting something for both sides, multiplying both sides by a number, dividing both sides by a number. You could do one of those legal math moves to get from one equation to the other. The essential understanding, though, at the beginning stages here was equations are equivalent if and only if they have the same solution. So any equation that is going to have a solution of 3 and another equation that has a solution of 3 as well, they are going to be equivalent equations. This first problem right here was talking about a person who is buying 5 candy bars from the store, and the equation that represented it was 5c equals 6.25. And A, B, and C were just talking about interpreting the actual equation and trying to figure out what the equation meant. Now, a lot of times you look at something like this and you assume it means $5 per candy bar times the number of candy bars equals the 625. But in this case, they've already told us that there were 5 candy bars. So that must mean the 5 is the number of candy bars. And if you already know the number of candy bars and you're multiplying by something to find out the total cost, then the other number, or the variable C, has to represent the cost of a candy bar. So A was saying 5 is the number of candies, C is the cost of a single candy bar, and 625 is the cost of all the bars. When you solve this, no matter whether you're guessing and checking or actually dividing both sides by 5, you get 1.25 or $1.25, and the meaning of that solution is it is $1.25 for each candy bar. The equation 10c equals 12.5, the meaning behind that, comparing it to the original one, was that 10 candy bars must be $12.50. It's just doubling the number of candy bars must be double the price. And this actually brought us to a kind of a cool connection here. We know that 5c equals 6.25, meaning 5 candy bars being $6.25, and 10 candy bars being $12.50 is basically the same situation, just different numbers of candies. So what we found was that if you multiply one side by 2 and the other side by 2, you basically get the same situation. Why is it the same situation? Because both of them result in a candy bar being $1.25. So what that brought us to was finding out that if you do legal, the book calls it legal moves, and that is, as I said, adding something, the same thing to both sides, or subtracting the same thing from both sides, or multiplying both sides by the same thing, or dividing both sides by the same thing, you will always end up with equivalent equations. So when we look at this example right here, you explain the different legal steps that they did. They distributed, then they combined, then they subtract 2 from both sides, and then they divided 5 on both sides, divided by 5 on both sides. And all of those are legal moves. So what we know is that the top equation, the next equation, the next equation, the next equation, and the next equation must all be equivalent. And we learned that a solution to one equation will be a solution to all of its equivalent equations. And if you look at this, the bottom equation says some number equals 2. So what is the only solution to that? Well, the only number that x can be to make that a true equation would be x equals 2, which means that the solution to 5x equals 10, since it's equivalent, is also 2. And the solution to 5x plus 2 equals 12, since it's equivalent, must also be 2. And the solution to all of them must equal 2. So when you go over and you solve an equation using these, as they call it, legal moves, or you are using inverse operations to get the x by itself, you are basically making a bunch of equivalent equations which all have the same exact solution. Now, and that's what we said on the second essential understanding. When you are solving equations, you're basically making a bunch of equations that are equivalent. It says you try, come up with an example of an equivalent equation to 2x equals 10. So since we know 2x equals 10 has a solution of 5, any equation that you go over and make that also has a solution of 5 will be equivalent to it. Once again, that is because both of them will have the same solution, but also, for example, the 2x plus 10 and the 4x equals 20, all I have done is multiplied both sides by 2, which is a legal move. This other one, you are multiplying, it appears, to get to 5x equals 25, you are multiplying both sides by 2.5, which is a legal move. Or you could do multiple things, like you did on that right equation, getting 5x plus 1 equals 26. On this one, I was just trying to prove that this was actually true on the top example. Once you know that the solution is 5, I just wanted students to substitute 5 in at every step of solving the equation to show that they're all equivalent. And the easiest way to see if they're all equivalent is to make sure that they all have the same solution. This next equation just says, what happens if you solved an equation and the variables went away, but you ended up with a false equation, such as 8 equals 1? If you're solving an equation and the variables go away and you end up with a false equation with just numbers, that means no solution. And I don't know why it says fake. It's supposed to say false equations indicate no solution. Maybe that does say false. Anyways, if you end up with a false equation, that means no solution, no value of x would make that equation true. And if you go through everything and you get a true equation, let's say it ended with 8 equals 8, which is true, that would mean every single number you could think of that you substitute in would make it true. This next problem right here was just going over and showing that this equation could be solved, except for that last step is done differently. I know on the right it says add 1, but it was supposed to say divide by x. And the reason, no, it does say divide by x. The reason why that method does not work is because you're dividing by x, and x can be any number. But the problem is if x can be any number, not only can it be 1, 2, 3, 4, but it can also be 0. And you were saying that you can divide by any value of x, but if x was 0, you're trying to divide by 0. And the problem with that is you're not ever allowed to divide by 0 in math. It becomes undefined. So that method of when you get to that step of 2x equals 3x, rather than subtracting 2x like they did on the left and getting an answer of 0, if you divided by x, you are saying that you're allowed to divide by 0, and you can't. The last part of the notes was a column A, which showed a step that they were doing to solve an equation, and asking what was that step that they did that was a legal move that resulted in equivalent equations. So going through these, the first one was they distributed, which is totally legal. The next one, they subtracted 2x from both sides, which is legal. The next one, they multiplied by -3. As long as they do it to both sides, you end up with equivalent equations. And the last one was combining like terms, which also results in equivalent equations. Now in column B, these are all things that they did that do not result in equivalent equations. For example, in the first one in B, they added 5x on one side, but they subtracted it on the other. They did the different things to different sides. You can read through the rest of these. Like I said, on the second one, it is they didn't multiply the left side by 2. There was always something they did where they only did it to one side, or they did something that just wasn't legal, or they forgot something and they did not end up with equivalent equations. Now let's take a look through the homework real quick. So problem number 1 says, which of these equations are going to be equivalent? So there's a few ways you can do this. You can get an equation and see if you can do those legal moves to get from one equation to the other, meaning adding something to both sides, subtracting something from both sides. That can get a little tricky. The way I did it was I just found out what the solutions were. I solved each one of the equations. And once I solved each one of the equations, any equation that has the same solution as another equation must be equivalent to it. So that is how I did that problem. On number 2, it says what is the legal move that they did to result in equivalent equations. And when you look at this, you can see they got rid of that -3 by dividing by -3. So that would be D. On number 3, it says, this is just a review from previous sections, is 0 a solution to this? To check if something is a solution, you just sub it in and see if it makes the equation true. On number 4, it says, write a convincing explanation as to why this is true and what you're trying to prove is true. It says, Kieran says that the solution for that first equation must also be a solution to the other. The only way that they would have the same solution would be if they were equivalent. So my way of explaining that they must have been equivalent was showing that there was some legal move that they did that connects the two equations. And you can see that they just multiplied the first equation, left side and right side, by 5 and ended up with the new one. So they multiplied both sides by 5, and that is why they are equivalent. It is just the same equation, kind of the equivalent equations. I shouldn't say same. Number 5, me being the silly person I am, didn't realize that it was a multiple choice question and it was asking what does X represent. In this situation, you should have realized that X represented the delivery fee. I thought it was asking part A, B, C, and D, so I answered each one of them. You could take a look at this. It's asking the cost for each potted plant. I thought it wanted you to look at the equation and look at the numbers and figure out which one was the cost of the plant, which was $750. You have 36 people, so that was the answer to D, and the total cost was $320. But I misinterpreted the question. Now the next thing was just looking at graphs and making sense of the graphs. So this was saying a person spent $40 on donuts and loaves of bread, which I spelled wrong. There are different variations. They could buy all just bread, all just donuts, or some combinations of donuts and bread and end up with $40. So the first question said, what is a graph? Like, what is the line represent? And a line just represents all the possible solutions to this situation. It would be all the combinations of bread and donuts that would add to be 40. It says, what does point A represent? Well, it's a solution, meaning 6 donuts and 7 loaves of bread would be $40. Part C is, what does B represent? That is 5 donuts and 2 loaves of bread. And since it's not on the line, it's not a solution and it must not be $40. Next one says, are 10 donuts and 1 loaf of bread a solution? Well, if you look at the point 10-1, it is not on the line, so the answer is no. And then based on the graph, how many loaves of bread would you need if you had 14 donuts? If you go to 14 on the x-axis, go up to your line and go over to the left, you will see the y connection with that would be 3, which means that 14 donuts must also have 3 loaves of bread. The only question that I forgot to put on here that I wanted to put on here was, should the points actually be connected? And since you cannot buy part of a loaf of bread or part of a donut, then technically it is discrete, not continuous, and those should all be dotted. It should only have dots at the actual solutions. Hopefully that helped out. Thanks for watching.